Hopefully it's recording. 3, 2, there it goes. All right, so one of the things that is unintuitive, I think, is the book talks about on page 70 and 71 about the idea of interpreting things as true or false. And so I think the easiest way to think about this is if something exists, we consider it true. If it doesn't exist, we consider it false. So they have what they call their maitre d' program. And I am going to open that up really quickly and take a look at it, and we can see if that makes any sense. So I'm not going to spend a lot of time on this, but we'll use this again in the future. So, nice big giant program. Is that easier to read on that font? Good. All right. So, basically it's got a couple of print statements and says we're going to print welcome to Chateau de Foods, blah, blah, blah. And then it says money equals input. How many dollars do you slip the maitre d'? And we do another step here, and we've already seen that, where we take the integer of that. So we convert that input into some form of a numeric. And then we simply say, if money, I do something. Whoa, wait a minute. But do we actually compare money with anything? We're just saying if money exists, so if there is a value in money, this is going to print, I'm reminded of a table, else I'm going to say it may be a while. And so I'm going to run this one really quickly so you can see, and it's going to pop up in the other window naturally. Hang on. So how many dollars do you slip the maitre d'? And I'm going to put 0. And it's going to say, oh, please set. It may be a while. Well, I'm going to run it again. And this time I'm going to give the maitre d' a $20 bill. And it says, here's a table. And so this is really kind of a shortcut, but it also works on the idea that it evaluates as true or false. So if true, so if there's a value in money, it's going to cause this to run. Otherwise, it's going to do this. And so we can try it. We can try to trick it up a little bit. And we could say, well, what if I put in a negative $20, what happens? And it still takes that value. It really is, unless it's 0, it doesn't evaluate it as false. And so the book talks about that on page 71. 72 says, well, what if we create a counter and we intentionally want to create a infinite loop? Now, I can't think of a time when I would really want to do that, but there is a way we can get out of a loop. And so one of the ways we're going to show you is something called a break statement. Now, it's, in my opinion, not a great programming technique. There's other ways and better ways to do this. But if we have something that goes wrong, it can be used as our escape to get out of a loop that went horribly wrong. And so we'll take a look at one here. So File, New, and I'm going to save this somewhere. So I'm going to once again go, here's my program. And we know that generally loops, if we don't have a way to get out of them, are bad. So we're going to create a loop. And so we're going to do a couple of things. So I'm going to set equal a value called count, and I'm going to explicitly set it equal to 0. I'm going to use that assignment operator. And maybe I'll use this technique we just learned a little bit ago, and I'm going to just say while true. So in other words, this is going to go in a loop and run forever, and I'm going to say count equals count plus 1. And maybe I want to print that count just so I can see it appear on the screen. So I'm going to do a couple of things here. So if I ran this right now, And I probably do want to put my input so it'll hold open. Press some key. All right, so now if I run this, and I need to save it with some, so infinite loop, it's just going to sit there and run forever. Gives us an idea of how quick the computer can count. Doesn't do a whole lot more than that. And again, I can break that manually by doing a Control-C. And that Control-C says, well, you just put a break in there. So what I might do is if I would like to, just as a precaution, because I didn't intend maybe to do this, but I can put in an if statement. So if count greater than 100, and then I put a colon, which bumps me down and inside, then I could just use the key phrase break. And so we'll see if this will run then. It gets to 100, 101. Wait a minute. So I got to look at my logic a little bit here. And so it says greater than 100. So I would really probably, if I wanted it to stop at exactly 100, say equal to or greater than. Oop. I put that on the wrong side again. All right. So we can force it to stop. Not the most elegant way to do it, but it does kick us out of that loop. Now, there are some other things we can do. We can actually continue a loop. So one of the things we could do is we could actually put a continue statement in there. So we could say if count is equal to, say, let's do 17. We'll do a continue. So what that's going to do, when and if my count gets to 17, it's going to jump back up and start over again. So let's take a look and see what happens if I run this then. So if I scroll back up to where it hits 17, it's going to just continue through and run that. So we can use those not necessarily as a way we control the loop. Most of the time we use these techniques as a error chap to see if we have something that does that. So on the bottom of page 73, it kind of tells you that and says, all right, we know that those aren't necessarily the best ways to do things, but if you think about it, at the end of a whole list of if statements, that you could use those as a way to double check and make sure that your loop doesn't go into an infinite loop, it's a good way to do it. Or if you break something, you can use that continue to recreate and set back up. So you'll see those again, and we'll show them to you once we get into some slightly bigger products. So one of the things I want to do is I want to look at the idea of adding compound conditions to things. Oh, compound conditions. So this is something a little new. So I'm just going to use this same program, and I'm going to just change it here, and I'm going to say program to demonstrate compounds. And so I'm just going to delete my little loop we'd made earlier. And I don't necessarily have a whole lot I want to do in here, but I want to show that we can do a couple of different things that we can do. And so I'm going to get an input from somebody, and that input, we're going to get a username. And so I'm going to put in a couple of things. So I'm going to put in username, and I'm going to set that equal to a blank, just by default. That way we don't have any garbage going in. And then I'm going to get an input, username, please. Now, what I'm also going to do is I want to be able to loop this so it will happen over and over again. And so I'm going to put this inside of a while. So I'm going to put a while loop that says while not username. So what this is going to do, and this sounds weird, is as long as you put in something, it's going to continue or not loop. So let's try it and see what it does. So I'm going to save that. And it says username please. And if I just hit enter and I don't put any content in, look what that does. It re-loops that. So as soon as I put in a username, so if I put in Mike, it's going to continue to loop. So I get that ability to create a loop really, really quickly. So we also need to get from the user, we're going to put in a password. And so I'm going to explicitly state in here, password is equal to blank. And so I'm just going to steal this really quickly. So similar structure, but now I'm going to change username to password. And then I'm going to say input username please. Now, one of the things I need to do in here is I really need to get that to set to the same thing. So this is where it's a little odd. So I'm going to say username equals that input. And here I'm going to say password equals that input. And so now it's actually got something to check against. So I'm going to run it. Username, and if I don't put anything in, doesn't work. As soon as I put in Mike, it should be able to check that against that. So we'll have to see what I've done if I've spelled something wrong. So we'll take a look at that here in a second. So we have a username and we have a password. So we're going to get multiple events in. All right. So we're also going to check against a couple of events. So this compound condition, so if username is equal to, and I'm going to use the Mike, just because I like Mike. And so we're going to do two conditions, and notice it changes color. And password is equal to, let's use secret, and we'll probably use that on all of them. So if that condition occurs, we're going to say hi, and then we can get username. And so we can print out what that username is to them. Welcome to the club. So in this case, we're using a compound, and that's what we're looking at here, is does Mike and secret both have to be true to get it to print out that? Yes. And so we could do an else. Welcome to the club. So whatever club that is. But we could also do an else. So else print your kind are not welcome. You do not belong to this club. And so we can do that check, and we can say, do both of those conditions have to be met? Yes. So we can do this then, and that will give us the ability to make sure that they actually put in a username. They have to put in a password, and here we can check to see if they belong to our club. Now, this isn't the easiest way to do it, because now what we could do is we could say, well, all right, we want to add some additional people to this club. Well, we could use that elif, and I'm going to just copy this piece to make life easier, because we're going to have the same questions for them. elif username equals Mary, and passwords equals secret. So I'm going to leave that secret in there. They could certainly have different passwords, but for our purposes, elif, and maybe another name is Sarah, and we're going to leave password alone because we already know there's no security here. So now we ask the question of, we get a username, we get a password, and both conditions have to be true in order to get the welcome to the club message. So let me save that. So username is Sarah, and password is secret. And it says, hi, welcome to the club. I got to change one thing I noticed here. Password, please. Just my own spelling issue there. All right, so username is Sarah, and secret is the password. Now, a couple of things. The reality is, would you ever put in a hard-coded statement where you put in their username and password? No. But for our purposes, it shows that we can check on two conditions. And so now, if I want to run this again, and I know that it's Sarah is one of our usernames, but I put in the wrong thing. I put in a password, you're kind or not welcome. You do not belong to this club. Because anything we do, it has to have both conditions to be true. So I run it again and I try, well, I know that Sarah and I misspell my own name, and password I put in correctly, and it's also going to error out. Both sides have to be the same. So, a couple of handy things out of this. This ability here, this while not, so while nothing exists, this will loop. That's a handy way to get details back out of my user. So if I were to come in here and run this program, and for whatever reason I wasn't putting anything in there, it's going to do this and run that loop forever unless I actually put in a name. As soon as I put in a value, then it's going to ask for the password. So those are a handy thing we do a lot just to make sure that we get some kind of an input in there. So before, while it's set to blank, this is false, and so that will loop. So while not true, I know that's kind of a backwards way to think about that. While not true, we can loop. So make sure you've looked through and you look at that particular piece. And you can do those. So pages 80 and 81 talk a lot about the idea of pseudocode, and we've already went over pseudocode a lot. And one of the things we do in here is we're planning a game. And the first game we're going to plan is we're going to play a game called Guess the Number. And so this Guess the Number game, and I'm just going to do it right in here. I'm going to delete all my comments here. So we're going to do this in pseudocode, and I'm just going to use this as a tool. So our pseudocode for a Guess the Number game really is pretty simple. So we have to pick a random number. We have to get a guess from the player. we have to report high or low. And then we need to repeat, right? So in other words, we're going to repeat these three actions until you get the correct number. So the pseudocode for this isn't really that horrible. Now we could make it more involved, but I want you to see the different steps in there. And so part of that, we could guess a number pretty easily. So we could guess a number really, really easily. So a couple of things we're going to need in our program. How do we get a random number? What are we going to need for that? We know we're going to have the import random, so we can get a random number. And I'm just going to make some comments so I can say setting random number. And we probably need a value for it. So I might just call it number. And I'm going to set it to random dot. And I like the rand integer just because it easily makes a number we can do between, generally these programs we do between 1 and 100, those kinds of games. We've set a number. We've already got that part down. And we might want to put something about welcome to the Guess My Number program, trying to guess between 1 and 100. So just something to say, welcome to the game, you're going to do this. So we need to get a guess from somebody. And so we could do that really, really easily. We're going to just say guess equals input, take a guess at the value of my secret number. So we need to do one more thing with that. What else do we need to do with this line? If I take a guess, can I really compare it yet? Can I compare if guess equals number? Can I do that? Can I compare those two? So why can't I compare those two numbers yet? What's the difference between these two numbers? And I can run this and see what happens. So I'm going to run it, and I don't have anything that says what's. I do. I defined it right there. I said guess equals input. Number equals random integer right there. The guess is not an integer. So I'm trying to compare a string to an integer. So the easiest way is just put that in one line. So integer of. So now I could run this program. Now, it doesn't yet really do much of a comparison. So if guess equals number, print, you win. So in this program right now, take a guess at my secret number, 50. No, I didn't win. So we don't have anything to do to tell us if we're high, if we're low. So we could do that with an if statement, right? So rather than do it this way, let's think about how we could put this in a loop. So what if we put it in a loop that said, while guess does not equal number, doesn't matter. Oh, and Comparison? Yeah. That it does. It doesn't matter which way we put these two values, though. So while guess does not equal the number, then we can do some actions. And that way, we could say something like if guess greater than number, print. So if our guess is higher, then you would want to say guess lower. And there's only really two conditions. Else, print guess higher. So we've taken care of both conditions. And so this loop then should be self-sufficient. So there's only one problem with this loop. Well, let's see what happens. Take a guess at the value. I'm going to put 50 in. Oh. Well, that's not good. So right now, it's going to loop forever because we don't ever change this value for guess. Number we don't want to change, but guess doesn't change because we don't have another input. So I'm just going to do this copy and paste because that's a handy way to do this. Now I'm going to change that value, but I also want to keep track of how many times that we do this. And so I'm going to try, we could use count equals count plus 1. So every time this loops, it keeps track of how many times you do this, and I'm going to have up here count equals 0, just so it starts it out. So now my loop's going to run until we get the right number. It's going to keep track of how many tries we have. So we might want to guess and put an output at the end of it. Print you guessed the number. It was number. And it only took you I think we used count. Yep, count tries. So in one statement, we list then the actual number and how many times it took them to try that. So now we can try it, see if we've got any really weird errors. So 50, I'm going to guess higher, guess lower, you guessed the number. I guess I should really probably call that guessed, but it was 59 and it only took you 6 tries. So 1, 2, 3, 4, 5, 6, 7. So why does it tell me that? Do I have another error logic I need? Yeah, so because it counts at 0, what I could really do, so there's a couple different ways I could do it. I could just do this, count plus 1. And then it will actually start at 0 or add 1 to it. So guess taking, I start at 50. So there's some logic to always splitting the middle of the difference. Now, I broke it because look what I did. I accidentally hit the plus key and it actually broke because that input couldn't figure it out. So let me try this again, see if my logic worked. 25, 40, 35, 34, 33, and then we have 1, 2, 3, yep. So that actually works. So now I can go up, I can clean up that program, and I can make the program work really nicely. So that Guess My Number, that's our first real program that actually worked, and we can make a game out of it. So the book has all about Guess My Number, explains every piece of it, just like we went through. They did things a little differently than we did, but you have something very, very similar that you can do then. So our homework this week, if I look at our homework, and I don't have Blackboard up, so somebody will have to help me with it. What's our homework this week? What are we supposed to do? So I'm just going to make a comment block, and I'm going to put my name in it. And we're to count to 1,000 flips, coin flips, and list how many heads, tails. Anything else we're supposed to do? Oh, so you're supposed to be able to create this program and actually allow users to run it multiple times. So we have a couple of things we probably need to do. So if I want to create a program that runs multiple times, I'm creating a loop, right? So I need to think about what I want to do inside that loop to start with. So to get a user, so maybe I need to put in, I'm going to just do a print statement just so it kind of defines what I'm doing. Welcome to the coin flip program. And I probably need to get and put this into a loop of some sort, the entire program, right? And so the first question I might ask is, so input, do you want to flip coins? Now, I need to preface this, and maybe I need to put in some more content. And I need to assign that to a value. What would be a logical term for a value like that? I'm going to just call it repeat. And I'm going to then create a loop. And my loop is just going to be a while loop. While repeat equals yes. And then everything's going to be inside of a loop inside of here. So my entire program is going to be inside this loop. Now, the flip side of this is at the very end of my loop, I need to make sure that I ask that question again, right? Because I need to change that sentinel value. So I'm going to grab this, and I'm going to put it in, and I'm going to put a comment above it. This changes the sentinel value. Or continue. So everything else is going to be above that. So if I'm going to flip coins, there's something I probably need to do right away at the very top of my program. What do I need actually in my program? My value? Okay. But before I can get a random number, what do I need to do? So I generally put that up at the very top of the program. So I want to see here, before we do anything else, if I can flip a coin. So we know we have import. So import our random. So I have a couple of things I want to think about. So how many sides does a coin normally have? So really, we have a head or we have a tail. Most of the time it's not going to land on the edge, right? So we're going to consider that those are the only things that can happen. So would it make sense for us to say head will equal 1, tails equals 0? Does that make sense? Okay. And I need to be able to flip a coin however many number of times. So I'm going to call this actually then coin flip times, just to make it easy. And I'm going to set that equal to our 1,000. Well, I need to create a loop that'll run 1,000 times. Can I do that? So I could say while coin flip times, but I really need another variable. So while we're just going to say x is less than coin flip times, and we're going to set x equal to 0. And inside of here then, I really need to do something then every time. So every time this program runs, I need to make sure that x increments, right? My counter in there. So I'm going to have an x equals x plus 1. So we can count through there. And I'm probably going to have something else then. I need to figure out if we're getting a heads or a tails. So we need some kind of a random flip. So I'm going to say coin equals random dot rand integer 1 comma 2, or 0 1, I guess we're doing 0 1. Sorry. So in this case, print coin, just so I can see what it looks like. So I'm actually going to put a comment tag in front of that, because for right now I'm not going to use it, and I'm going to put one in front of this one. So we'll come back to those. I just want to make sure we can flip a coin first 1,000 times. So I'm going to see what happens when I run this. On which one? Print coin. I do have parentheses on it. Because it's a variable, I don't need to put, you mean like quote marks? Well, X, this one right here. No, because I'm printing the value of it. I'm not printing coin. I'm printing the value of a variable in there. So I'm going to print, and I'm going to see what happens. I'm going to save it as coin flip. Do you want to flip coins? Well, yeah, we do. But it's not really asking or checking anything at this point. And so we hope that that printed 1,000 times, right? Is there any way we can check that? So right now I want to be able to check that. How could I check that this really did 1,000 times? the right program open. So how could I check and make sure that really did print 1,000 times in here? What if I printed, so right now I printed coin. What if I change that, and at the bottom of this, outside of that loop, I just did a print X. Because I want to see what that counter is at the end of my loops, right? So I'm going to run it again. And so it runs through hopefully 1,000 coins. Oh, look at that, 1,000. X is equal to 1,000. So let me look back at this logic again one more time. Because should that number be 1,000? So while X is less than coin flip times, and we set coin flip to 1,000, so does that seem like it's right? Or could we have an error in there somewhere? So X starts at 0 and counts up to 1,000. How many coin flips do we really have then? Oh. So while X is less than, or should we say less than or equal to coin flips? Would that maybe make more sense? Or do we want to leave it alone and see if that works? So you think just the less than works? So you want to do a less than equals? Okay. And it runs through and it gets 1,001. Wait a minute. How did that work? So we added the equals to, and it's actually, it counts up an additional one. So I'm going to say we go back to this and let's see what happens. We're going to be able to come up with a way to count those here in a minute. So we've got it where it runs and it seems to flip a coin. So coin is equal to, and it seems to run that 1,000 times. Probably we don't need to print those, do we? Because that's going to take up some screen time. We do need that X equals X plus 1 because that's our sentinel value. At the end of this, we probably don't really need to print X yet, but we may need something. So how do we tell if it's a head or a tail in here? So if it's a 0 or if it's a 1. So how could I create a way to keep track of heads and tails? Okay, how would I implement that? We set up here heads and tails, so we probably know we have some variables, so maybe we have heads, we're going to set it equal to 0, tails equals 0. So how can I increment and count those? How can I ask that question, is this coin flip a 0 or a 1? So I could use an if statement to say if coin, so if coin equals 1, or maybe 0 makes more sense, what could I do then? So if coin is equal to 0, is that affecting heads or tails? So how would I add a value of 1 to tails? Okay. So do I have an else clause on this? Because right now there's only two conditions. It's either heads or tails, right? So else heads equals heads plus 1. So So this isn't very pretty, but maybe we can see what happens. Oh, if coins is equal to takes the double equal sign. There we go. All right. Do you want to flip coins? Yes. Now, here's where we can also double check. And maybe our math skills aren't that great. So we can actually do this. So it actually checks for us. We could say, in this particular run, we had 590 or 510, not sure which way we have it in there, heads or tails, and 490 heads or tails, and a total of 1,000 flips. Yay, we have the 1,000 part down right. That part's good. Now, our program has a couple of errors and issues that we need to think about. Does it really allow you to repeat your choice yet? Does it allow you to repeat anything? No. So how might I get that to repeat? What might I do to repeat that? Okay, that's the start of it. But we're actually running this loop, and we start it down here, and I'll take that out. That one actually I'll need. Sorry. So what if we moved this loop? We know this runs, right? And we know we need the heads equals 0. We know that we need the x. So what if we did this? What if we took this entire chunk and we control X, so I cut it, and I actually put that inside of my loop here. Uh-oh, it did not like what I just did. Hang on a second. It didn't copy. Hold on, close, and I don't want to save, and I'll reopen it. What did I call that? Coin flip. Hang on, let me go reopen it. Coin flip. Well, I have some of it there. So I'm going to move this entire section. I don't need to change this coin flip 1,000 times. That's not going to change. But all of these values, every time this loop executes, copy, paste. So all of these need to be inside of that loop. But when I just copy it like this, is that going to work? What do I need to do to make this work? So they've got to be at the same tab level. So I'm going to come back in here and just try to clean that up a little bit. And this is the hardest thing to remember on these, are these tabs. So everything inside this while loop has to be at this tab level. And that's that block indent. So it says, hey, I'm going to run this. Because this is inside a second loop, it actually has to indent one more set. And there's actually some tools in there where you can grab an entire section and indent it. But I wanted to see it manually so I can show you what we've got to do here. So this loop is this entire block here. This loop is this block. So we've actually nested a loop inside of a loop. So our entire program nests inside this outside loop, and then our piece in here. So now that I did that, I can get rid of this up here, and that's what I tried to do in one quick statement. I'm going to recreate it here in just a second. So I just want to see what I have here. So I have coin flip is equal to 1,000, and that's really a set value. We're not going to change that anywhere. So I'm going to leave it up top. And this print statement here, I'm going to delete and make better. Because right now, if I left it up top, it's not going to do anything. We haven't actually created any action. So I am going to, inside of this loop, but at this level, I am going to create a print statement. And I'm going to print, you had, and so I'm going to print heads. So I'm creating some way to output that and say, I've got number of heads, and I want that all in one thing. Heads, and you had tails, and so that should output it very nicely. It'll say which is heads, which is tails. And you can do all different kinds of things to make that pretty. And in fact, if you leave it just the way this is, that will get you the C grade-ish part. So you need to make this look really nice. We still need this x equals x plus 1 because that's how we're counting that loop. But is that x equals x plus 1 even in the right spot? No. Where does it need to go? Correct. It needs to go in this second loop. And so now I can get rid of it. And so you might even keep track of that. You could say sentinel value increment for inside loop. So now, this should run. It's inside of this. So while repeat equals yes, so in other words, if I put in a yes, then this should run. But I don't have any way to change that again. So I need then to have this input in here. And that input needs to be at the level of this repeat loop. So notice those are all at that indent level. At the end of this program, I'm going to have a print statement that says, thank you for using our software. Goodbye. Just something to say I'm at the end of my program. And then I always need that input, a blank input. To exit. And you probably have those in your template. So now I can try to run this and see what happens. Let's just try it. And I get some kind of an error somewhere in here. Oh, I forgot to change that again. All right, so double equals there. Oop. So we're actually doing a comparison, so we need to make sure that works. And so now I get, do I want to flip coins, yes or no? And again, I see some errors. So one of the things that would drive me crazy in a production is my cursor is right next to this N. So I'd want to fix that. But for now, I'm going to type in a capital S or a capital Y. And I'm going to see if my program actually will let me run. You had 501 heads and you had 499 tails. Do I want to flip coins? Yes. But I put in a yes, didn't I? What? Oh, so I can change my program. There's a couple of different things I can do. The thing I would do with this, honestly, is on this input, is there a way we can make something uppercase? And I would figure out how I can make that input uppercase, and that way I don't care if they type in a lowercase or an uppercase y. That's in chapter 2, I believe, of this book. You can find a way to do it. You can also search any of those resources to do that. So I'm going to try it again just to see what happens. So I'm going to try running this program. And I'm going to say no to start with. And it should exit. And it does. It's not very pretty. I need to do a lot of cleanup on it. I'm going to run it again. And I'm going to see if I can get this to loop a couple of times. So F5. And I'm going to put a capital Y in. Pretty slick. I've got my whole program inside of a loop, and I can run it as many times as I want to. I can change that pretty easily. So it seems like it's got the right number when I check those. 509 plus 491 equals 1,000. If I wanted to change this to flip it 500 times, how hard would that be? I change one line. If I change this line, now what I'll tell you is my nomenclature is not right, because it's saying, hey, do you want to flip it 500? But notice it's actually flipping it 500. So you could even get that input. That might be a kind of a clever addition. You could add, so coin flip, set it equal to 0, and then actually ask that question in here, right after you said, do you want to flip coins? How many coins do you want to flip? And you could have it do that also. Bless you. So you could make this really, really neat and interesting. Or you could leave it at 1,000. If you put in here in your text, you're going to flip it 1,000 times, make sure you're actually flipping it 1,000. But if you call it just a coin flip program and you add that ability to change the number of flips, that might be interesting. If I can do this for coins, could I do this for dice also? Yeah. So we could actually modify this existing structure, and I could do it for a 6-sided dice. And I could keep track of how many times each side on a dice comes up. I could get even more involved. I could flip 2 dice and we could run those numbers on that. But we start with the idea of I can make my entire program repeat. So that's that outside loop. Now I can make this inside piece repeat. So the biggest issue I have when people are starting on these kinds of things is making sure those indents are at the right level so that the computer can see that block code. So if I had this hanging out here, that's going to tell this while loop that, oh yeah, that while loop's ending because I don't have anything in the block 1 tab over. In fact, you can see that if I try to run it, it's going to say, hey, that's not going to work for me. So keeping these tabs at the right level and making sure you see those programs. Putting in lots and lots of those comment tags is not a bad thing. And I can put them at the end of a line, which is also somewhat handy. So notice like I did with this one, where I just added at the end of it a pound sign, and I said, this is what that line does, just so I can make sure it does it. Down here I put it on top of it, and I said, this changes the sentinel value to allow my loop to exit or continue. So if I didn't have this in here, watch what happens. So welcome to the coin flip program. And I'm going to type yes once. And it's just going to run forever. And that's simply by, all I did was unhide that so it would run that. Now, I also have coin flip here I need to change because we had played with that a little bit. So what it really would look like is, so while that's interesting, that doesn't really solve our issue of that loop. So it's got to have an increment. So when we build loops, there has to be something that allows it to change. And so that's the biggest issue I see is people will build a loop and they have no way out of that loop. So that might be one way. We use this kind of real quick builds. So I know this seems weird. I'm just going to flip a coin 1,000 times. We use this to do what's called Monte Carlo simulations a lot. So we simulate what a number's going to be or what kind of a value it's going to end up at. And so by doing it repeatedly, that gives us a way to simulate something over and over and over again. So if we did it with dice, we could build a very similar game. Now we have 4 minutes left in class. Probably not going to be able to do that, but we can start looking at other objects, and they're very, very similar to this. All right, any questions on the homework? So you remember you have a discussion board also and this homework assignment. So if you get it to work and it's plain, so just so we can talk about the grading scale on that, that's a C. It needs to be professional looking in its output. This program I just wrote would be a C. It's sloppy. It gets the job done, but it's sloppy. So all those things about making it look nice, neat, professional, making sure your name is up there, making sure your output looks right. Because like this little thing about not having a space here, that's enough. Because that you've got the program code, but it doesn't look very good. And so we work a lot on how to make sure it's professional looking. So now, notice the difference in that opinions. Do you want to flip coins? Yes or no? Just by making sure I have that space and I have it looking a little better. So once I get this running, then I'm going to go through and I'm going to try to make that program look very professional. And then if I want to add additional features or I want to add additional content, that's when I do that. So I create the bones of it and then I start fleshing that out. Make sure you put in comment tags so you understand what's going on and you can explain it to me what's going on. All right, any other questions? Nothing? All right, I'm going to close this down.